Question No. 1. A company has its production VPC in the AWS 1 region in Account 1. VPC is attached to a transit gateway, TGW, that is connected to an on-premises data center in Dublin, Ireland, by an AWS Direct Connect Transit VIF that is configured for an AWS Direct Connect gateway. The company also has a staging VPCB, that is attached to another transit gateway, TGWB, in the AWS 2 region in Account 2. A network engineer must implement connectivity between VPCB and the on-premises data center in Dublin. Which solutions will meet these requirements? Choose 2. E. Configure inter-region VPC peering between VPCA and VPCB. Add the required VPC peering routes. Add the VPCB jitter block in the allowed prefixes on the Direct Connect Gateway Association. B. Associate TGWB with the Direct Connect Gateway. Advertise the VPCB jitter block under the allowed prefixes. Associate TGWB with the Direct Connect Gateway. Advertise the VPCB jitter block under the allowed prefixes. This will allow traffic from VPCB to be sent over the Direct Connect connection to the on-premises data center via TGWC. Configure another transit VIF on the Direct Connect connection, and associate TGW advertise the VPCB jitter block under the allowed prefixes. This will enable the use of the Direct Connect connection for VPCB's traffic by connecting TGWB to the Direct Connect gateway. C. Configure another transit VIF on the Direct Connect connection, and associate TGWB. Advertise the VPCB jitter block under the allowed prefixes. D. Configure inter-region transit gateway peering between TGWA and TGWB. Add the peering routes in the transit gateway route tables. Add both the VPCA and the VPCB jitter block under the allowed prefix list in the Direct Connect Gateway Association. E. Configure an AWS site-to-site VPN connection over the transit VIF to TGWB as a VPN attachment. Answer: BC. Question No. 2. A company's network engineer is designing an active-passive connection to AWS from 2 on-premises data centers. The company has set up AWS Direct Connect connections between the on-premises data centers and AWS. From each location, the company is using a transit VIF that connects to a Direct Connect gateway that is associated with a transit gateway. The network engineer must ensure that traffic from AWS to the data centers is routed first to the primary data center. The traffic should be routed to the failover data center only in the case of an outage. Which solution will meet these requirements? Set the BGP community tag for all prefixes from the primary data center to 7224, 7100. Set the BGP community tag for all prefixes from the failover data center to 7224, 7300. E. Set the BGP community tag for all prefixes from the primary data center to 7224, 7300. Set the BGP community tag for all prefixes from the failover data center to 7224, 7100. B. Set the BGP community tag for all prefixes from the primary data center to 7224, 9300. Set the BGP community tag for all prefixes from the failover data center to 7224, 9100. C. Set the BGP community tag for all prefixes from the primary data center to 7224, 9100. Set the BGP community tag for all prefixes from the failover data center to 7224, 9300. Answer: B. Question No. 3. A global company runs business applications in the East 1 region inside of EPC. One of the company's regional offices in London uses a virtual private gateway for an AWS site-to-site VPN connection on the VPC. The company has configured a transit gateway and has set up peering between the VPC and other VPCs that various departments in the company use. Employees at the London office are experiencing latency issues when they connect to the business applications. What should a network engineer do to reduce this latency? E. Create a new site-to-site VPN connection. Set the transit gateway as the target gateway. Enable acceleration on the new site-to-site VPN connection. Update the VPN device in the London office with the new connection details. B. Modify the existing site-to-site VPN connection by setting the transit gateway as the target gateway. Enable acceleration on the existing site-to-site VPN connection. C. Create a new transit gateway in the AWS 2, London, region. Pair the new transit gateway with the existing transit gateway. Modify the existing site-to-site VPN connection by setting the new transit gateway as the target gateway. D. Create a new AWS Global Accelerator Standard Accelerator that has an endpoint of the site-to-site VPN connection. Update the VPN device in the London office with the new connection details. Answer: Question no. 4. A company is using custom DNS servers that run bind for name resolution in its VPCs. The VPCs are deployed across multiple AWS accounts that are part of the same organization in AWS organizations. All the VPCs are connected to a transit gateway. The bind servers are running in a central VPC and are configured to forward all queries for an on-premises DNS domain to DNS servers that are hosted in an on-premises data center. To ensure that all the VPCs use the custom DNS servers, a network engineer has configured a VPC DHCP option set in all the VPCs that specifies the custom DNS servers to be used as domain name servers. Multiple development teams in the company want to use Amazon Elastic File System, Amazon EFS. A development team has created a new EFS file system, but cannot mount the file system to one of its Amazon EC2 instances. The network engineer discovers that the EC2 instance cannot resolve the IP address for the EFS mount point 334567d.efs.us-est-one.amazo and AWS.com. The network engineer needs to implement a solution so that development teams throughout the organization can mount EFS file systems. Which combination of steps will meet these requirements? Choose 2. E. Configure the bind DNS servers in the central VPC to forward queries for efs.us-est-one.amazo and AWS.com to the Amazon-provided DNS server 169.254.169.253. B. Create an Amazon Route 53 resolver outbound endpoint in the central VPC. Update all the VPC DHCP option sets to use Amazon-provided ANS for name resolution. C. Create an Amazon Route 53 resolver inbound endpoint in the central VPC. Update all the VPC DHCP option sets to use the Route 53 resolver inbound endpoint in the central VPC for name resolution. D. Create an Amazon Route 53 resolver rule to forward queries for the on-premises domain to the on-premises DNS servers. Share the rule with the organization by using AWS Resource Access Manager, AWS RAM. Associate the rule with all the VPCs. E. Create an Amazon Route 53 private hosted zone for the efs.us-est-one.amazo and AWS.com domain. Associate the private hosted zone with the VPC where the EC2 instance is deployed. Create a record for f334567d.efs.us-est-one.amazo and AWS.com in the private hosted zone. Configure the record to return the mount target of the EFS mount point. Answer: BD. Question no. 5. A company has deployed a new web application on Amazon EC2 instances behind an application load balancer, ALB. The instances are in an Amazon EC2 auto-scaling group. Enterprise customers from around the world will use the application. Employees of these enterprise customers will connect to the application over HTTPS from office locations. The company must configure firewalls to allow outbound traffic to only approved IP addresses. The employees of the enterprise customers must be able to access the application with the least amount of latency. Which change should a network engineer make in the infrastructure to meet these requirements? E. Create a new network load balancer, NLB. Add the ALB as a target of the NLB. B. Create a new Amazon CloudFront distribution. Set the ALB as the distribution's origin. C. Create a new accelerator in AWS Global Accelerator. Add the ALB as an accelerator endpoint. D. Create a new Amazon Route 53 hosted zone. Create a new record to route traffic to the ALB. Answer: B.